Scientists, are you ready for a virtual field trip? From sunny Los Angeles, let's go to the California Science Center with your hosts, Mariela and Monica, with a special appearance from
Dr. Ken Phillips.
Let's go to the California Science Center.
Hi scientists, and welcome to our virtual field trips at the California Science Center. Before we get started, there are a few things we need to go over.
All virtual field trips will have a question of the day. And today's question is, how do you choose the best materials for a design?
Pause the video now to write down the question of the day in your notebooks. And don't forget to write down or draw things that you observe in the video to help you answer the question of the day.
All virtual field trips will also have a buzzword. Today's buzzword is properties.
Anytime you hear this word, be sure to make check marks or tally marks somewhere in your notebook to keep track of how many times you hear the buzzword. Can you count them all?
Before I forget, there might be times we ask you to pause to think about a question. You'll see this sign and hear this sound to remind you to pause. Okay, scientists, I think we're ready to begin. Follow me. Welcome to the Samuel Ocean Space Shuttle Endeavour Pavilion. We wanted to start here to show you this. As you look at Endeavour, it might seem like it is made out of some sort of heavy metal that would make it strong enough to get to space. But actually, Endeavour is made of a lot of different materials that make it light enough but still strong enough to travel through space. Let's take a closer look at some of the parts of Endeavour to learn what it's made of. The wing and the nose are the strongest parts. They are made of metal. This part is the reusable blanket. It helps to protect the shuttle from extreme temperatures. Part of the Endeavour are made of these tiles you see here. They help improve strength, durability, and resistance to cracking. Wow, there are so many materials that make up this shuttle.
That's right, Monica. Now scientists, we thought that today we can complete an engineering challenge. We want to design a spacesuit that will help us stay safe and complete some tests while we're floating in space. Now, this won't be an actual suit that we put on. We are going to design it on my tablet. To create a successful suit, we have 3 tests that our suit must pass successfully.
Test 1. Our suit must pass a hardness test. It must be able to survive getting hit by tiny objects in space called micrometeoroids. We will need to explore the hardness of materials that will provide protection and be appropriate for our suit. Test 2. Our suit must survive an insulation test. Insulation means a material that is used to stop the movement of electricity, heat, or sound from one place to another. For our suit, we need to make sure to pick an insulator that will protect us from extreme temperatures so we don't get too cold or too hot in space. Test 3. Our suit must pass a flexibility test. As we make our suit, we need to make sure that we can still move comfortably to work while we are in space.
Okay, let's get started on our design. Uh-oh. I need to reboot my tablet actually. Monica, maybe you can take the scientists to the California Science Center and get some information about materials we can use for our spacesuit.
Good idea, Mariela. What should we keep an eye out for?
That's a great question. Scientists, as you explore with Monica, make sure you focus on the properties of materials. A property is how we describe an object by how it looks or feels. As Monica takes you around to explore, think about the properties of materials that might help us make a suit that will be successful in all 3 tests.
Great! I know the perfect place to start. Let's go, scientists! Let's begin by thinking about what our suit will need to complete its first task, hardness. Our suit needs to be strong enough to withstand anything that might hit us while we're working in space. Here on display, we have a few capsules that have actually been on missions to space. This is Gemini 11. Its mission gave us the first view of Earth as a sphere. The scientists who created this capsule needed to think about the properties of different materials that would work best for it to complete its task. Gemini 11 is made out of materials like titanium, fiberglass, and hard plastic that make it lightweight, but still strong enough to stay protected on its mission. Okay, scientists, I brought my science satchel with me so that we can think about the properties of some materials for our spacesuit. Let's see what we have here. A ruler, a t-shirt, and aluminum foil. If you have these materials around you, pause the video now so that you can investigate with me. Just like the capsule, we need to pick materials that will protect us in space. Let's investigate closer. What properties are you noticing about this shirt? Ooh, so soft and pretty stretchy. Let's check out this next object, a ruler. This one's not as soft, but it is pretty strong. Wow, actually, it's very strong. This might work, scientists. Now let's take a look at the last object, foil. This feels different from the others. Wow, this is pretty light. And if I fold it into layers, it feels pretty strong. Now that we have investigated these materials, which of these materials might be helpful for our suit? These observations are all great to keep in mind when we design our suit with Mariela. I know another place we can explore. Okay, scientists, so we've explored the hardness of our suit. So now we need to talk about our second test, insulation. Remember, insulation is when a material can protect you from extreme temperatures. What do you think the temperature is out in space? Is it warm like the desert or cold like the poles? Well, I guess it depends where you are in space. Some places can be extremely hot, but most of space is very cold. So, let's check out our polar zone. This way. This is our extreme zone, poles. Once inside, you feel the chill and explore adaptations polar animals have to help them survive the cold. So what better place to explore than here? Remember, our suits need to insulate or protect us from the extreme temperatures so that we don't get too hot or too cold. Now I know that we can't make it to space to test out the materials from the science satchel, but check this out. This is our ice wall. Here we can try out different insulators to see which best protects against the cold. Time to check out what I have in my science satchel. Fleece, feathers, and paper. Remember, scientists, we need to think about how the properties of these materials might help with extreme temperatures. If you have these materials around you, pause the video now so that you can investigate with me. Let's start with this fleece. Remember, we want to think about the properties of this material to see if it will be a good choice to use on our spacesuit. This fleece is soft. I wonder if it will help keep the cold away from my skin. I know! I'm going to place this fleece between my hand and the ice wall to see if it protects me from the cold. Wait, is this ice wall even cold? Ooh, it's so cold! Whew. Let's see how well this fleece works. Wow, I don't think I can feel the cold. Definitely not as cold as when I place my bare hand on the wall. Okay, I wonder how this second material will work. This is a bunch of feathers. These feathers are light and super soft. The properties of these feathers sound like it will work great with the suit. Now it's time to test out the feathers on the ice wall. Oh, scientists, these feathers are not absorbing the cold as well as I thought. I can feel the coldness. That might not be the best option for space. One more material to try, paper. So, this paper is not as soft as the fleece. It's smooth but stiff. Maybe it will keep the cold away from my hand. Let's find out. The paper is better than the feathers, but I'm not sure that it's better than the fleece. As I keep the paper here longer, it is absorbing the water that makes the ice, and the coldness is starting to make the paper weaker. Now that we have investigated these materials, which of these materials might be helpful for our suit?
Great! So we've thought about the properties and materials that would help the hardness and insulation of our suit. Scientists, I think I know one last place we can go to help us with our suit. Come on. Whoa! Look at the divers here at the California Science Center.
Now, I know that astronauts do some of their training underwater to help them practice what it will be like to be floating in space. Take a look at what our divers are wearing. Notice that the divers have their whole body covered by their suit. This is important to make sure their skin isn't exposed. Their suits are made of a material called neoprene. The properties of this material are important. Neoprene is a great material for these suits because it insulates the diver's body so they don't get too cold. Neoprene is also thick, but as you can see, it is flexible. The divers are still able to move around underwater to complete their tasks.
Great! Scientists, I think it's time to explore our final test, flexibility. Let's go. Let's find out what 3 things we'll be testing out. Let's see what we have in here. We have an oven mitt, okay, a rubber glove, and a baseball glove. Wow, all of these are so different. Now, just like the divers had a task to perform, we will too. For this test, I will be building a structure out of blocks that looks like this. I will build the same tower using each glove to see which glove will allow me to do it the fastest.
If you have these materials around you, pause the video now so that you can investigate with me.
All right, scientists, I have my glove on and I'm ready to go. Give me a countdown from 3. Are you ready? 3, 2, 1, go! Well, that was fun and a little challenging to do with some of these gloves. Which glove do you think we should use for our suit? I think we have finished our exploration, and now it's time to head back to find Mariela so we can design our suit. Let's go. Hey, Mariela, we're back.
Perfect timing. Let's make our suit. Monica, how about you share what you learned and I can draw it?
First, we need to make sure our suit is strong enough to keep us safe from objects in space. To make sure our suit is hard enough, I want to select foil, which is made out of aluminum. One of the things we learned about aluminum is that the more layers it has, the stronger it is. So I think our suit should have a few layers of foil.
I like your thinking, Monica. Adding foil to your suit.
Next, I need a layer of a material that will protect me from the temperature in space. From our investigation with the ice wall, could you add a layer of fleece to my suit?
Here?
Actually, it needs to go underneath, Mariela. If it's over the foil, it might not protect my skin, and the foil can protect the fleece from getting ruined by micrometeoroids.
Oh, gotcha. Like this?
Perfect! I can see the blue fleece peeking through the foil. And the last material I want to use will go under the fleece. I want a layer of rubber. When we explored flexibility, the rubber glove allowed me to move easily to build the tower, and I was able to do it in the shortest time possible. Can you add rubber gloves and boots?
Okay, now that we have our suit, let's test it out. First test, hardness. Activating micrometeoroid shower. Wow, those micrometeoroids are bouncing right off your suit. First test, success. Second test, insulation. Activating temperature reduction. Well, some of that coldness got in, but not much. Second test, success. Third test, flexibility. Oh no! Our satellite got damaged from the micrometeoroid shower. Monica, drill the panel to fix the satellite.
Success!
You did it, Monica! These are the materials that Monica picked. What did you use for your suit?
Wow, what a great pretend suit! I know someone we can talk to that can tell us more about what materials scientists use to design a space glove. Let's go.
Hello scientists, my name is Dr. Ken and I'm the curator for aerospace sciences here at the California Science Center. And I'm in a special storage room where we keep some of our artifacts. I hear you were testing out materials to find out more about their properties. Well, here at the California Science Center we have some amazing artifacts that were used in space by astronauts. Check this one out. This glove is called an EVA glove that astronauts use when performing spacewalks. Any ideas about what EVA might stand for? Well, EVA stands for extravehicular activity. So this glove is used when astronauts are working outside of the space shuttle. Let's take a closer look to understand what this glove is made of. And let's start with the outside of the glove. As we look closer, draw what you see and write down what you notice. Do you notice the gray part of the glove? What do you notice about it? Whoa, do you see these ridges on the surface? Why do you think they're there? Now look at the back of the glove. What do you think the white part is made of? Does it remind you of anything you've seen before? Take some time to share what you think with someone around you. And if you need extra time for drawing and thinking, pause the video or rewatch what we just saw. Now scientists, let me tell you about the glove and what it's used for. Well, the outer part of the glove is protection for the inner glove. This outer part provides thermal protection for the astronauts since they're working in extreme temperatures. Think about a time your hands have gotten super cold. It might be hard to perform a task with cold hands. The gray part is made of flexible rubber and neoprene. As you may have noticed, the gray part has ridges along it. And this helps give astronauts a better grip when using tools. Can you imagine dropping something while working in space? It might just float away. Astronauts have to take extra care to make sure they keep track of their tools. They're attached to the astronaut suit with either ropes or Velcro to keep them from floating away. It doesn't happen often, but believe it or not, astronauts have dropped things before, like a spatula, a camera, and pliers. Let's look underneath the top layer. And remember to draw what you see and write what you notice. Wow, what do you notice, scientists? Can you tell what this yellow material might be made of? Why do you think this part has holes in it? Interesting. I wonder what the purpose of this tube is. This inner glove has a rubber inner layer that attaches to the arm of the spacesuit to form an airtight bond. This is very important for astronauts since the air they need to breathe is inside their suit. These holes are where the glove gets attached to the rest of the spacesuit. Now, what did you think this tube was for? Well, did I mention that space is cold? This tube actually helps astronauts warm up their fingers. In each finger, there are miniature heaters so that each finger stays nice and toasty. This tube carries an electrical current to help keep those mini heaters on. Well, scientists, hope you enjoyed taking a closer look at our EVA glove. Bye-bye.
Let's design the perfect shoe. For this activity, you'll need a piece of paper and a pencil. In our sketch today, you'll draw the perfect shoe for an imaginary place. You can draw a single shoe, 2 shoes, or you might even want to draw different angles. It's up to you. Make sure to label the parts of your shoe to help others understand what you're thinking. When the pause button comes up, make sure to pause the video to think, talk, and draw. Let's get started. Fold your paper like this. Each box will be a new shoe for a different place. Listen to what this place is like. This imaginary place is full of mountains. These mountains are very steep and rocky, which might make it challenging to walk. Also, this place is very, very hot. I'll place this sticky here so we can remember what this place is like. Rocky and hot. For this place, I'm going to draw and think. I'm going to start by making the sole of my shoe. Now, since I need to walk up these mountains, I'm going to design the bottom of my shoe to make sure I won't slip. It will be made up of sharp spikes made of metal. That will definitely help me make it up these steep and rocky mountains. Since those spikes are very hard, I'm going to make sure that the sole of my shoe is made of soft rubber that will make it more comfortable and flexible for when I'm walking. Finally, I can't forget that this place is extremely hot. I need to make sure to design something that is comfortable so that my feet don't get too hot while I'm traveling. I am going to design the top of my shoe to look like a sandal. What kind of shoe will you make? Take a moment to think and talk about what you're thinking about before you draw. Now, check out these scientists and their design for the perfect shoe. Let me tell you about our next place. Our next place is very cold. The surface we are walking over is very icy and slippery. As you can see, there seems to be water, but we can't walk over the water since we don't want to get wet. What kind of shoe can you design that would be perfect for walking over this place? Take some time to think about what you're going to make. What materials would be best for walking over the icy floor? Will your shoe be made out of felt so you can slide over the surface to move faster? What if you want to move slow? Could making the bottom of your shoe out of wood help? Think outside the box, scientists. This shoe is imaginary, so no idea is too wild. Okay, I think it's time to draw. Check out the designs of these scientists for the perfect shoe. Let me describe our third place. Our third place is this forest. Now, it may seem like this place isn't too out of the ordinary, but the floor is squishy, and if you stand for too long in one spot, your feet sink into the ground. Also, notice those cool looking fruits? Well, they are actually as heavy as a brick. Oh no! What kind of shoe can you design to help you from sinking into the ground? Take a moment to think and talk about what you're thinking. Don't forget those heavy falling fruits. Think about the hardness of your shoe so you can protect your toes. Okay, it's time to draw. What does your perfect shoe look like? Check out what these scientists drew. Do they look similar to your perfect shoe? Finally, our last place. Let me tell you more. The floor of this place is covered with water. If you were to walk here, you would notice that the water reaches up to your knees. And the ground that you see is full of moss, and it's slippery. This is tricky. Let's think and talk about what we might design. What does the perfect shoe for this place look like? What might make it easier to walk through water? Or maybe over the water? Is there anything that could help you from slipping on the moss? Now that you've shared, it's time to sketch what you're thinking. Let's take one last look at these scientists and their perfect shoe. It was great drawing with you, scientists. Now, back to the discovery room.
What a great field trip! Let's go over all the things that we did today. We started our field trip taking a look at the properties of Endeavor. Then we explored 3 places in the California Science Center to investigate hardness, insulation, and flexibility. Then we got behind-the-scenes access with Dr. Ken to take a closer look at a space glove and the properties that make it perfect for space. Finally, you got to design the perfect shoe for an imaginary place and think about the properties and materials that would make them perfect for walking in that place. Now, scientists, do you remember the question of the day?
How do you choose the best materials for a design?
Can you use the buzzword to answer the question of the day?
Properties. Pause the video now to try to answer the question of the day using the buzzword.
Okay, scientists, it's time to count our tally marks. How many times did you hear the buzzword?
Pause the video now to count your check marks or tally marks.
And the answer is
9.
We hope you had fun on this virtual field trip at the California Science Center, and we look forward to seeing you next time. Bye.
For more virtual field trip fun, visit our website.